Hello everyone, welcome to Equal to. In the last video we saw a few methods of separation of mixtures, and in this video we are just going to continue with new methods for some more methods of separation. So if you haven't watched the previous video yet or the videos before that in this chapter, go and check it out in our playlist This Matter Around Us Pure. We have 8 videos so far and this is the 9th one. And also if you like these videos and want more of these, consider subscribing to Equal to. Now moving on to the next method of separation. So we are given a mixture of salt and camphor and you are supposed to separate the camphor from the salt in this mixture. Okay, now a property of camphor that we know already is camphor changes directly into gas from solid on heating. Okay, so this is something that we know. Camphor is something that we might have already used in our homes. It is something that we are familiar with in our day-to-day life. So camphor, as we know, directly changes from solid to gaseous state. So a method that you could use to separate salt from camphor could be heating it so that it evaporates and becomes into gas, and then you can cool it to convert it back into solid. Okay, so this is something that you could use. Whereas salt, it doesn't sublime, it doesn't become gas on heating. So that is something that we know, and we can use this property to separate camphor from salt. So that is exactly what we are going to do. We are going to take a burner, we are going to place a tripod over it, we are going to take a china dish and have this mixture in it, the mixture of salt and camphor, and you are going to place a inverted funnel over it. In that inverted funnel, you are going to use a cotton plug to seal the opening of the inverted funnel. Now you are going to start heating this. Now once you start heating this, the camphor will get heated along with the salt in that mixture, and the vaporization point of camphor would occur, and at that time camphor would start becoming into vapors and they reach the walls of the funnel. And since camphor cannot escape because we have used the cotton plug to seal the opening, camphor has to cool down with the surroundings of the funnel. And after this process, you can just scrape away the solidified camphor from the walls of the funnel. Okay, so this is the sublimation process that we can use to separate camphor from salt. Now what we have done here is taking sublimable volatile component away from the non-sublimable impurity. Here the salt is what we call as the impurity and camphor is the sublimable volatile component here. Okay, now a few more examples where this process can be used is ammonium chloride and also naphthalene and anthracene. These are some more things that vaporizes, that sublimes and becomes gas, and that can be separated using the same sublimation process. Okay, now we are moving on to the next method. The next method, here we are going to do an activity where we are going to separate the different colors present in black ink. So let me first tell you the apparatus. You have a vessel in which you have some water, and water is going to act as a solvent here. Now you are going to take a filter paper and you are going to place a point of black ink in there, and you are going to hang this filter paper with the help of a clip into this vessel. So the filter paper touches the water and you are going to draw a line where you have marked the black ink. Okay, now what happens is that water, it starts rising in the filter paper. So water gets absorbed by the filter paper and water levels start rising, and once it crosses the start point, which is the line that you have drawn and where the black ink has kept, right after that you will start seeing different colors appear on the top of the filter paper. Now why is this happening? That is what you are going to see now. Okay, now as water rises on the filter paper, it takes along with it the dye particles. Now we placed black ink. Black ink has both dye and water in it. Now water is the solvent that we also have currently in the vessel, and this dye is soluble in it. Okay, so this dye, it is dissolved in the water that is being rising with the vessel's water. So the filter paper, it absorbs the vessel's water and the water level is rising in the filter paper, and that water absorbs the ink, that is the dye that is present in the ink. Okay, now this dye is a mixture of two or more colors generally, and the different colored components in that dye have variable levels of solubility in water. So let us say red dissolves, for example, this is for just an instance, it's not factually correct, but for you to understand, let us say red dissolves faster in water. So what happens is that the red component in that ink dissolves faster in water, and it is the one that rises first. It is the one that gets in the what do you say, filter paper. Okay, so since the colors in the black ink are having variable levels of solubility, they rise in different manner and they appear in different spots in the filter paper. So colored component that is more soluble in the ink, it rises faster when compared to others. Okay, so this is the component, this is the concept that is used in chromatography. Now this is what we call as chromatography. We are separating different colors from it, right? That is what we call as chromatography, and chroma means color in Latin. Now this technique can be used to separate solutes that are dissolved in the same solvent. Now in case of black ink, we have the same solvent, which is water, and in water there is different colors of dye mixed together and dissolved in that water to become ink, and that can be separated using chromatography. So there are different solutes, but the solvent is the same, which is water. Okay, and a few applications of chromatography are colors in a dye. You can separate colors in a dye using chromatography. You can also separate pigments of natural colors, like the colors from leaf, those sort of things. Pigments of natural color can also be separated using chromatography, and also drugs from blood. This is a medical application where drugs in your blood can be separated using chromatography. Now those are quite advanced chromatography techniques. We don't use a filter paper to separate that, but chromatography is the principle that is used there. That is different components mixed in a mixture having different solubility in water or different solubility in that solvent can be extracted. Okay, so that is the principle, and that can be used to separate it. Now moving on to the next separating method, here we have two miscible liquids. In previous video, we saw separation of two immiscible liquids using a separation funnel, but here we have two miscible liquids, meaning you cannot tell them apart. You cannot see where they split up. They don't settle down, or they don't form a layer over other, telling you that they are immiscible. These are miscible liquids, so they combine together and they get into each other very well. So the technique that we are going to use is that it's called distillation. So for example, we have a mixture of acetone and water. Acetone is the chemical that you use in your nail polish remover, and acetone is mixed with water. Both are colorless, so you cannot tell them apart. Now the thing is that acetone, when you put in your hand, it instantly gives you a cooling effect. You might have observed this. When you use a nail polish remover, you would feel cold. If you put it in your palm, you can feel the sense of cooling effect. Okay, this is evaporation that we have seen in the first chapter. So what we know is that acetone vaporizes quite quickly. Now water, it takes some time to boil. So two miscible liquids that boil without decomposition. So this is something that is very important. Some liquids on heating, they decompose, meaning the chemical nature of them is entirely changed. They are something else on heating. They are not like, if let us say if we have a chemical X that is a solution, and on heating if it becomes another chemical, something completely different from it, that is what we call as decomposition. Its individual components get split up. We will be seeing more about this later, but this is what I am trying to tell. Its nature itself is changing. So those sort of chemicals cannot be used, cannot be separated using distillation. Distillation is for liquids that boil without decomposition and have sufficient difference in their boiling point. Now in this case, acetone has a lower boiling point when compared to that of water. Now when you heat this mixture, acetone becomes gaseous, acetone becomes vapors quickly, and then it is moved to the condenser, which is water condenser. It passes water through it and it cools it, and then it is moved to that. So the gas formed on heating, it's then cooled and it is collected in a beaker. Now after doing this, you will be left with water in the distillation flask. Okay, or you can also take the acetone away and heat it more to make the water become as vapors, and also again condense it and collect it in another beaker. So this is how distillation works. Now for this to work, the boiling point difference should be higher. Okay, now why is this, why should this boiling point be higher? That is the reason that we will see in the next slide. So to separate a mixture that is having more than 2 or more liquids, and also the boiling point difference is 25 Kelvin, we use a technique called fractional distillation. So why we cannot separate liquids that have boiling point difference less than 25 Kelvin? The reason is that it takes time for your normal distillation. It takes time to cool it down and convert into liquid, but the 25 degree Kelvin, it's easily achieved when you heat it heavily. So in that case, normal distillation, there wouldn't be enough time for it to cool down. So what we have done is that we have come up with something called fractional distillation. Okay, so in fractional distillation, the apparatus is very similar, but we also have something called fractional column at the above of the fractional distillation flask, and the condenser is connected to the fractional column. So what happens is that the beads in the fractional column is just a glass tube with some glass beads. The glass beads, they provide surface for the vapors to cool and condense repeatedly. So these glass beads, they provide a surface area, and as surface area increases, the cooling effect also increases. Okay, so they remain cool. These glass beads, they remain cool and they allow the vapors to get cooled easily, and then they are passed on to the water condenser and it is collected as liquid. So this fractional column, it improves the condensing effect, and that is why in fractional column, in fractional distillation, we can easily separate liquids that are, we can separate a mixture of liquids that is more than 2. Okay, so we can separate a mixture which has more than 2 components in it. That we can do with fractional distillation. And also if the difference in boiling point is less than 25 Kelvin, fractional distillation is the way to go. So that is all for this video. We have seen what distillation is, what fractional distillation is. We have seen chromatography and also how we can use sublimation to separate things. So I hope you understood these concepts. If you have any questions, please put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video. If you haven't seen the previous ones yet, please go and watch them first. And also if you like these videos, consider subscribing to Equal To. Thank you so much for watching. See you in the next one. Bye for now.